saving best for last. This is grade 11 general physics, of course, and this has been a very long journey. Got so many videos done. I hope you're all subscribing. Okay, so we're starting with rigid body. What is rigid body? Well, basically it's something that will not bend or twist or move. It'll move, obviously. The whole point is it will not change its shape. It will move around, it can spin, it can do anything, but the distance between any 2 points will remain the same because the shape doesn't change under stress. That's a rigid body. So it says it can change shape under stress. That's terrible. That's not true. It doesn't change shape. It stays the same. Remains in a fixed position? Well, not exactly. The parts are fixed, but it can rotate. The whole thing can spin, so it's not exactly correct. Mass distribution is uniform? No, it doesn't need to be. It could be something big. I have no idea what I'm drawing. It could be very heavy on one side. Looks like an elephant. Something very light on the other side, so that's not true. The distance between 2 points remained unchanged, exactly. So if I had this little elephant and I had a position here and a position here and I rotated it, these two will have the same distance no matter which position it's in. I hope you get the idea. Now, let's see what's next. One complete revolution of this is equal to this. Okay, so you're just converting. Firstly, obviously, we know that 360 degrees is 2 pi. So 360 degrees is the equivalent to 2 pi. That is a big circle. A full circle is 2 pi. That means a half circle will simply be pi, and so on. That part's not important, but what is important is this. Alright, so 360 is equal to 2 pi. That means if you ever wanted to do some sort of rearranging or solving, because it might not ask for one full revolution, it's very easy to do so. You'll take your 360 and you're going to multiply by, and you'll make a little fraction. If I want to cancel the 360 degrees, I will put it underneath divide and cancel. Divide by 360. This is the relationship. These are the numbers. So it has to be 360 here. And at the top, 2 pi. Putting that in your calculator, well, obviously you're just going to get 2 pi, right? That's exactly what you're going to get. What if I said to you something along the lines of, I don't know, 180. I mentioned pi. I mentioned half of that. So it should be pi. 180 degrees. What do you do for this? Multiply, divide. So this is my relationship up here. I'm going to cancel my degrees and I'm going to put 360 degrees down here because that is the relationship, 2 pi. 180 times 2 pi over 360, stick that in your calculator and you'll simply get pi, which is what we would expect. If you were given something like this, pi over 2, and you wanted to convert that to degrees, you must be able to do that as well. Let's give that a try. So I'm going to do pi over 2, multiply by, this time I'm cancelling the pi. I have to put that underneath. What's my relationship? 2 pi. 2 pi and then 360 above. If you do that, 2 pi and 360 above, put that in your calculator, you should get 90 degrees. Let's move on. So that's a lot of stuff right in there. Too much reading. Let's move to the question. If an object is rotating counterclockwise, what can we say about its velocity? So that's easy. Counterclockwise basically means going up that way, yes? This is counterclockwise. Clockwise is down this way. So the exam question might ask for clockwise. So in that case, this is kind of going up. It's kind of going towards the upward side. So we'll call that positive. This is kind of going down. So we'll call that negative. Usually up is positive and down is negative. So this is kind of close to going up. So that's the reason why. So we're going to pick positive for counterclockwise. It will be negative for clockwise. Filling in the blanks, as an object rotates, the change in its angle, that is simply the angular displacement. Alright, if the angular velocity is negative, that means negative means clockwise, right? Negative is clockwise. Good thing I wrote that. Clockwise. Very nice. Then, we're moving on. For a rigid body to rotate around a fixed axis, every part of the body has the same. So basically, if it's moving, no matter what you're doing, the actual angular velocity, angular velocity is the same. As well as, one more thing, obviously if it's moving, and it could be having a speed, it could even be changing its speed. If it's changing its speed, we just call that angular acceleration. Acceleration is a change of speed. Acceleration. Spelling is not important. My handwriting is not important because you can hear me talk at the same time. So hopefully that will make up for my horrible handwriting. Okay, so let's continue on. What we're doing now, we're looking for something that will produce a maximum torque on the wrench. Okay, so the formula is written here. I have normally written it as FD sine theta, which is the same as this. F is F, D is my R, which is the distance, and sine theta. You're looking for a big force and a big distance to have the big torque. This is nice, I have a double the force, but the distance is almost zero. That's too close, so that's not good. This one has a normal force and I'm only halfway up. So that's okay, not amazing. The furthest one is great because not only is it far away, it also has double the force. So you could say it's double the distance, double the force. I have no actual markings of distances, but I can clearly see this is the furthest and it's the strongest. So that means I will pick C. How is the torque produced by the force on the wrench? How is it produced? By moving, obviously. So what's happening is this torque will be moved because you can see this is moving this way. It is rotating. It is rotating. And what direction is that? We can call that clockwise. It's following the clock, right? It is rotating clockwise. Clockwise. So if I make a perpendicular force, it will make it rotate because it's stuck to the pivot. Obviously it wants to go down, but because it's stuck to the pivot, it's going to just keep sticking to the pivot. The force is going to keep sticking to the pivot. And that's why it's like a bit of a circular motion going on over here. Very nice. Now, over here, a boy, he pulls on a wrench and he has a force and it's got an angle. Find L if he makes that torque. So this is L. So that's very nice. So all we need to do is we have the force, we have the angle, we need the L. That L is basically the distance. The force, not the force, the torque equals F, usually I write D, right? FD sine theta. So I will rename that to L. So torque we have it. 35 equals the force, we have it. 52 multiplied by, I'll call this L, multiplied by sine, and we have the angle. The angle is here, sine 40. Sine 40, I need to get closer. Sine 40. So if you were to stick that into your calculator, hopefully you'll get the answer of 1.05. Very good. Now we have another thing which is to do with torque again. What is it asking for? Length again. So it gives me an inkling that the final exam will probably ask you for length as well. So that means torque equals F, I will write L this time, sine theta. Torque we have, it says here, Newton meters, that's the unit for torque. So it must be 15 equals the force, we have it, that's newtons. Force is 70 multiplied by L, that's what I need, right? Multiplied by sine of the angle 50. You can rearrange, you can do shift solve. Most of you are doing shift solve, so I'll just stick with that. Putting that into your calculator, you should get 0.28 meters, that will be. And of course, if you want to put it into centimeters, you just simply multiply by 100 because it's 100 centimeters in a meter. So that would be the answer. The resistance to rotation. The resistance to rotation, this is not the resistance of movement, so it's not going to be moment or resistance. And it's not a torque because that's something moving. Friction is just rubbing, so these are all terrible. Moment of inertia, that's good. Inertia, by the way, means resistance. It means resistance to movement. It does not want to move. That's inertia. If we start talking about rotation, we add the word moment. Moment is rotation. So this is rotation. And this word here literally means resistance. Resistance is a Latin word. Very nice. Resistance. So that's the idea here. Very good. Now we have to illustrate when work is positive, negative, or zero with suitable examples. Well, clearly we have examples now with these little boxes, so let's find out here. For work to be done, we must have a force and we must have a distance. A bit like the torque above there. If we want to do work, I need a force and a distance. And of course there's an angle as well, cos theta, so it's a dot product, so we'll have a cos theta. Not important, but what is important, looking at this, we have work which is greater to the zero, which means there is some work happening, and this is telling me this is going to the right. So work is a positive number, this is going to the right, so this will be going to the right. This will be positive work. Positive work. This is work is zero, no work is done, and is moving to the right. So in this case, well, it's moving. And if the work is zero for it's moving, that usually means either there is no force or the force is perpendicular. So if there is some sort of movement, it has to be maybe perpendicular, because cos of 90 is 0, by the way. So it would either be perpendicular, or there will be no force, no force. It is just simply saying, if I am standing here, I am holding my suitcase and I'm holding it up, but I am walking forward instead. I am walking forward with my suitcase. I am not doing any work on this. It is not moving in any direction. No matter how much I pull up and down, I cannot make it stop going forward or left. So this is perpendicular, no work is done. In this case, work is less than 0. So if work is going to be less than 0, so that simply means a negative number. Less than 0 is a negative number. This is going to the right, that is a negative number. So that will be possibly going to the left instead. So it's opposite. So it'll be negative. And this looks like the same as these, but with just the answers hidden. So it's the same thing. So what we've got here, positive value for work, moving to the right is positive work. This will also go to the right. No work being done is possibly perpendicular, or there is no force. In this case, this is less than 0, which is a negative value. That's moving to the right, so that means the work will be also negative in this case. If it was negative and it was moving to the left, then this would still be positive work done, by the way, but just keep that in mind. It's moving to the left, so that's the negative side. Now we need to do the calculation with the formula that I wrote at the top. So we have the work done it's asking for, we have a distance right here, we have a force right here, and we have an angle right there. So it's really straightforward. FD cos theta is the formula. F is my force, 200 newtons. Distance, of course, is 5 meters. Meters is good, so don't need to convert anything. And 45 degrees, cos 45. Plug and play, put that into your calculator directly. Hopefully you'll get the answer of 710, or around there to round it. Energy of motion. So motion means moving, and moving, the term for that is kinetic. Kinetic energy is to do with moving. Stored energy, like gravity for example, will be potential energy. Power is how fast you use energy, energy over time. Work is what we've done there, applying a force over a distance, that's work. So motion, kinetic energy. Classify into translational and rotational kinetic energy. So what is that supposed to be? Translational and rotational. Translational just means a straight line. Rotational means circular. Still, what does that mean? Well, let's say you have a car, and here is the wheel of my car. For some reason, I only have one wheel. There we go. It's a terrible drawing. And I'm moving this way. This wheel is rotating. If this rotates, the car moves forward. That's what it means. This is the rotational, and this is translational. That's all. So which of these involves rotational? Driving on a highway, that's a straight line. Baseball being thrown, moving in a straight line. Spinning top, so it's something spinning, that's correct. Running, that's also a straight line. So that's the idea. If I asked you for the other one, you would look for whatever's in a straight line. What is the energy transformation when something is released from a height above the ground and moves downwards? So for example, if I did have a cliff, and this is the ground, this is my cliff, and I am standing here and I take the iPad of one of my annoying students and then I release it and I drop it. It's going to land on the ground with a big thump and hopefully break. So right now, at the top, this is stored energy, this is potential energy, gravitational potential energy. As it moves, it gets faster and faster and faster, and it hits the ground, it becomes kinetic energy just before hitting the ground. So we're going from gravity to kinetic. So gravity to kinetic, A is the answer. Not kinetic to gravity, that's wrong, because I'd started with a speed of 0. I released it, I dropped it from rest. Thermal, not exactly. There is no air resistance, no friction, so there will be no thermal energy there. Potential to sound. This is actually kind of true. Potential, when it hits the ground, there will be sound at the end. But the main thing is it hits kinetic energy first. After it hits the ground, it will transfer into sound. So it's actually gravitational potential to kinetic, and then maybe to sound and whatever. So at the very top, this is basically the opposite of there. Now you have a ball, you throw it up, it goes up, and then it'll maybe come back down. At the very top, I clearly have a height, mgh, right? I have a height. But the speed at the top, for a split second, it slows down, stops, and then it comes back down. So at this point, at the very top, the speed is 0. So we don't have any kinetic energy. Kinetic energy maximum, wrong. Potential energy maximum. Yes, that's the highest point, so this is maximum. Kinetic energy is 0. Correct. That is good. I like it. Both of them are maximum is wrong. Kinetic and gravitational both are 0. Wrong, because gravitational is maximum. Okay, so this video is getting a bit long. I'm going to do E equals mc squared, or I'll do some more of the energy questions in the next video. No, thank you.